Hello, this is the demo for uh, assignment 3 Schoolab E, where I had to create, a notebook which uses, TensorFlow only from scratch and does not use any high-level API. And one part is TensorFlow only with the built-in layers of the same, and third was functional high-level API, and third was uh, only TensorFlow but using high-level API. So I have done all these four in a single notebook, which I'll be showing now. So yeah, I've created a 3-layer neural network. So first variant is low level, where I'm doing manual weights, calling the gradient tape, and doing the raw back propagation. Then I'm using Keras sequential functionality. Then I'm using Keras functional API, which is Keras dot input, layer graph, and model, and then the subclassed model, which is the PyTorch style model. So for all the four variants, I'm using the same data, which is the sign data plus some noise. So this is the data shared by all the four variants, and this is how I'm creating it using NumPy's random function and linspace and sign function. Once that is done, I'm just plotting the data. This is how the data looks. It is pretty much a sinusoidal wave. Then let's move to the first variant, which is low level TensorFlow. So here I'm manually, I'll manually create the weight matrices and bias from TensorFlow.variable, and use the TensorFlow.gradient tape to compute gradients and update weights by hand, and there's no Keras using at all. So excuse me. So this is the weight initialization. I'm just using the TF variable, again TF variable. Once that is used, I'm creating W1, W2, W3, V1, V2, V3, and these are my parameters now, which will get changed using the gradients. Now this is my forward function, where I'm defining my layer. So first is nn.relu. This is the activation function, basically passing on the output of input matrix multiplied with w1 plus b1, and then it is passing to the activation, and we are getting the layer 1's output. Then that layer's output is input to this layer, doing the same thing. We are getting h4, and then h2 is again doing this, and we are returning the values. We are not putting any activation, as it's a regression problem. This is now after once that forward, this is the forward pass. Now let's see the training loop. So this is the learning rate, and I'm storing all the losses in this list. So I'll just run it for 2000 epochs. For each epoch, I'm initializing this gradient tape, which is which will calculate my gradients. And so I'm just calling the forward for input x, and this function, basically I'm just calling it, and this is the output I got. Now using that, I'm calculating my loss, which is again the mean square error, sorry. And then I'm just back propagating the gradient, and once that is done, I got the gradients in my grads, and using that, I'm just manually updating my parameters. Parameters are these things, the weights and biases. Based on that, once the update is done, I'm appending all the losses and just printing it. Now let's see how the loss worked. This is the loss going down, but let me just show you. Yes, so this is what the original data was, and this is how my prediction did, which is not it means it didn't work well. My neural network did not work well, but this is how, like, I am building my neural network from scratch in TensorFlow. Now let's move to the second variant, which was using, let me just go back. Yeah, only built-in layers, using the built-in layers. So here I'm using the Keras sequential layer, which will, Keras sequential function, which will, create the layers, and I don't have to explicitly mention what has to happen inside the matrix multiplication and all that, but yeah. So here I'm just using the tf.keras.sequential, and I'm passing my layer details over here. So I want a dense layer, an input layer, like the activation function and the size. Then this is the second layer, and this is how the third layer will look. And yes, once that is done, I'm just printing the summaries. Summaries is basically total parameters, total trainable parameters, non-trainable parameters, like that. Then we are compiling it, and we are now calling our optimizer, and with the loss and optimizers are called over here. Now we are fitting our model. We are fitting our model, and and all the details are stored in the history. And we'll just plot the loss from the history over here. So here you can see, as the epochs are increasing, the loss is going down. But let's see how the prediction actually worked. So see, blue was our original data, and red is how our prediction is, which is pretty much, it did quite well. So yeah, so this was using the sequential API. Now the second was used to use the functional API. So yeah, let's define a directed graph of layers using keras.input. So it is useful when you need multiple inputs or outputs or skip connections or shared layers. So here I'm creating this input layer using the input. I'm just passing it and calling it as that it's input, and then hidden layer is again called like this, and then hidden layer 2, and this is how the output will look. Once that is done, I'm just calling the keras.model, and I'm passing it the inputs and outputs. And as you can see over here in the dense, I'm passing the size, activation function, this and this also. So it means it it gives the sequence of how the layers will be called. So that is happening over there. So when I'm doing this keras.model, when I'm creating the model, I'm just giving my input, output, and and just a name. So once my function model is there, I'll just print my summary. Summary is how the layers look like, how many parameters are being processed, like that. So once that is done, let's again now compile. For compiling, we need an optimizer and a loss function. We did pass that. Then we will just fit the model for 500 epochs, and we'll see how the output looks. So here you can see the loss with each epoch is reducing, and let's see the plot. So yeah, again you can see it has very well found the data as a pattern. Now let's move to this subclass Keras model, which is additional functionality, and it's actually more flexible, and it mirrors PyTorch NN module style. So if you are familiar with that, so you can reuse this one. So here so here I'm just like we did in PyTorch, we will just create a class, and we will inherit the properties of keras.model. So like we did in PyTorch, we used to do this, and then nn.module, which will inherit from nn.module, and then we just initialize our variables, update the forward function, like that. So it's very similar to that. So we'll just take all the properties from the superior class, and this is the layers which we are defining. So FC1 is first layer, which is a hidden layer and activation function. Second layer is again hidden function with activation ReLU, and then we have an output layer. So now call is where we are defining how the layers will be called. So first we'll call FC1, and then FC2 will be called, and then we'll return the output of FC3. So yeah, then we'll initialize our instance, and then again we'll compile, and so in compile I'm just passing the optimizer and loss, and then I'll call my fit for 500 epochs, and then let's see how the output looks. So here you can see the output, the loss is reducing after each epoch, and here also you can see the model by very accurately predicted the pattern of the data. So that is it. There's one thing I also did was this training step. So overwriting the train step inside the subclass for full control over the training loop, while still using model.fit. So best of both worlds. So here what I'm doing is again I'm creating the layers, I'm creating the loss tracker while initializing. Once that is done, when I'm calling it, I'm just calling it one inside another, and yeah, I'm just putting the step training as false. Now we are just calling function of one another. Yes, then we have this custom training step. So in this training step, I am I'm doing the steps which we did in the training loop. Yeah, this is my data, which is x and y. I am calculating my gradient tape, initializing the gradient tape, and based on y predict and the loss. I'm predicting the my bad. So yeah, so inside the class instance, the class only, I am doing my training, and I'm calling my training, and I'm getting my y predictions. Then I'm calculating the loss, and the gradients are calculated, and we are getting again using the optimizer, we are updating the values, and we're tracking the loss, and we're getting the value. So yeah, that is pretty. So when we are calling it, so earlier all these things were happening outside, if you can see here. So we did model fit and the compilation outside. Now these things, these things are happening inside, and then now look at the output. It is able to get the data properly. So thank you.